Welcome to NPTEL MOOCs course on Computer Vision and Image Processing, Fundamentals and Applications. In this class, I will discuss one important application of computer vision, that is gesture recognition. Gesture recognition has many important applications. One important application is human-computer interactions. So, I will discuss about all these applications and also what are the major challenges of gesture recognition that I am going to explain. And mainly I will discuss the concept of hand gesture recognition. And in this discussion, I will discuss two important algorithms. So, briefly I will highlight the concept of DTW, that is dynamic time warping, and also the concept of hidden Markov model. So, briefly these two concepts I will be explaining related to gesture recognition. So, let us see what is gesture recognition in my next slide. So, this is the definition of gesture: a movement of a limb or the body as an expression of thought or feeling. So, this is the definition from Oxford Concise Dictionary, that is the definition of gesture. So, there are many applications of gestures. So, if I consider only hand gestures, so hand gestures also have many applications. One is the replace mouse and the keyboard. That means without using the mouse and the keyboard, I can interact with the computer with the help of hand gestures. Also, I may consider pointing gestures, maybe for robotic interactions, the human robot interactions, or maybe for window menu activations. So, I can select the window menus based on the pointing gestures. And like navigate in a virtual environment, that is the VR application, virtual reality application, and no physical contact with computer, because I can interact with the computer by using hand gestures and communicate at a distance. So, these are the some human computer interface using gestures, the hand gestures. So, in this case I am showing one interaction system, that is by considering the data globes. So, here you can see I have the data globes. In the data globes I have optical or the magnetic sensors. So, these sensors detect the movement of the fingers, the movement of the hand, and the globe is connected to the computer. So, computer will get the signals corresponding to the movement of the fingers, the movement of the hand, and based on this I can recognize different types of gestures. This is the globe based system. The next system is the vision based system. So, here you can see I have a camera. So, here in the figure you can see I have a camera. So, the camera detects the movement of the hand, the movements of the fingers, and after this the computer can recognize the movement of the hands or the gestures, or it can recognize the finger spelling. So, this is a pattern classification problem, because I can recognize different gestures, different finger spelling, and in this case I may have one camera or maybe two camera or multiple cameras. So, in this case globe is not important. So, the camera will detect the movement of the hand, and also it can detect the movement of the fingers. So, if I compare these two systems, one is the globe based system, another one is the camera based system, that is the vision based system and the globe based system, you can see advantages and disadvantages of. If I want to compare these two systems, one is the globe based system, another one is the vision based system, the both has advantages and the disadvantages. So, if you see the globe based system, the advantages are data is very accurate, because I am getting the signal from the globe, and mainly we have the optical sensors and the magnetic sensors. So, that means I am getting very accurate signal from the data globes, and not much computing power required in case of the globe based system. But the disadvantages are, because user has to wear the globes, that is the disadvantage, and this globe based system is not available for recognizing facial gestures. So, these are the advantages and the disadvantages of the globe based system. And if I consider the vision based system, one main advantage is that user does not have to wear anything. That is one important advantage. And disadvantages like we have to do complex computations, because we have to do the image processing, and since we have to consider different lighting conditions, the cluttered background, So that means we have to do lots of image processing, and that is very difficult. And sometimes there may be a problem of occlusions. So hard to see the fingers by the camera. This is nothing but the occlusion. So these are the comparisons between the globe based system and the camera based system. So I want to show the elements of the vision based interface. VBI means the vision based interface. So these are the research area in which you can do research in computer vision. So like hand tracking, hand gestures, arm gestures, head tracking, gaze tracking, lip reading, face recognition, facial expression recognition, body tracking, activity analysis. So these are the elements of vision based interface. So any one of these topic you can do research in computer vision or maybe in machine learning. Now I will consider the major attributes of hand gestures. So I may consider static gestures or dynamic gestures. For static gestures, hand configuration is important, that is the poster, and for this I need the information of hand shape. In case of the dynamic gestures, finger movements without changing the position of the hands. Then in this case I can consider the hand shape information. But if I consider hand movements in the space, then I have to consider the hand trajectory and the hand shape. That means in case of the static gesture, only we have to consider the hand shape information, but in case of the dynamic gesture, it may have local motions or the global motions, or maybe the combination of the local motion and the global motion. In case of the local motion, only I have the motion of the fingers. In case of the global motion, I have the movement of the hand. And generally if I consider the sign language, suppose, then in this case it is a combination of both local motion and the global motions. So these are the major attributes of hand gestures. So here you can see I am showing some static gestures of American Sign Language. So in this case I need the information of the hand shape. So with this information, that means the shape information, I can recognize different static gestures. And here you can see I am showing some of the dynamic gestures. So here you can see the movement of the hand and also the finger movements. So that means in this case I have both local motion and the global motions. So this is one example of dynamic gestures. So in this video I have shown that sign language, you can see some American Sign Language, and in this case the computer has to understand these signs of the American Sign Language. For this gesture recognition system, that is the human computer interface system, it may be unimodal system or the multimodal system. So for this we can consider the vision based system, that means the camera, or maybe the audio based system, or maybe the sensor based system like the data globes. In case of the multimodal system, we can consider one or two modalities. That means I can combine the vision based and the audio based, or maybe the audio based plus sensor based I can combine. So in case of the human computer interface system, I may have unimodal system or the multimodal system. And if you consider the gestures, so there are many types of gestures. One is the body gestures, one is the hand gestures, one is the head and or the face gestures. So in my discussion I am mainly considering the hand gestures. As explained earlier, I may have static gestures or the dynamic gestures, and I can consider the isolated gestures or the continuous gestures. So in case of the continuous gesture, I can perform all the gestures continuously, that is like the fluent finger spelling I can do, or the continuous gesture I can perform. But in case of the isolated gestures, I can perform a particular gesture at a particular time. So to understand these concepts, mainly the constraint on vision based gesture recognition for human computer interaction, you may see this research paper. This is our research paper. So I think you can see this research paper, you can understand the concept of the vision based gesture recognition for human computer interaction. So there are many applications of the vision based gesture recognition system. VGR means the vision based gesture recognition system. So one important application is the sign language recognition. Another one is robotic interactions, and also for the healthcare there are many applications like the laparoscopic surgery by using the gestures, or maybe the window menu activation by considering the hand gestures. One is the human computer interactions, the human computer intelligent interactions, and some applications in augmented reality and virtual reality. So here you can see the sign language recognition. Here this is the sign language recognition, and this application is in virtual reality, and this is in the healthcare applications. This is the robotic interactions. So there are many applications of VGR, that is the vision based gesture recognition. But the major challenges of gesture recognition I am going to explain now. In case of the vision based system, we will consider only the camera. Globe based system has the advantages, but the vision based system has the flexibility because user need not wear the data globes. So the camera will detects the movement of the hand or the movement of the fingers. But there are many challenges of the vision based gesture recognition. So one is the segmentation of the hand from the background. So in this case we have to consider different illumination conditions, random illumination conditions, and also we have to consider the cluttered background. So segmentation of the hand from the background, the cluttered background, and under different illumination condition, that is one research problem. And also the second problem is the occlusion. So there may be self occlusion between the fingers because the camera cannot see all the points of the hand or all the position of the fingers. So we have to consider the occlusion. The self occlusion is one important aspect, so that we have to consider. And sometimes the depth information is also very important. So if I consider only one camera, it is not possible to determine the depth information. But if I consider maybe the stereo vision system, then in this case we have to estimate the depth. With the depth information, the recognition performance increases. So how to determine the depth information, that is also one important challenge of gesture recognition. And already I have mentioned about the illumination changes, because for different illumination I have to do the segmentation of the hand and also the tracking of the hand, and the background may be cluttered background. And also we have to consider the 3D translation and the rotational variance. That means we have to consider the translation variance and the rotational variance. So we have to extract the features which should be invariant to translation and the rotation. That means we have to extract the hand features which are invariant to affine transformation, that is the translation, rotation and the scaling. So another problem is the spatio-temporal variation. That means if a particular gesture is performed by different persons or the different users, there will be spatio-temporal variations. Even the same gesture is performed by the same user or the same person, there will be spatio-temporal variation. So these spatio-temporal variations we have to consider. And also if I consider a continuous gesture, then in this case we have to find the starting point and the ending point of the gesture. So how to do the segmentation? If I do the gestures continuously, that is the continuous gesture. So how to do the segmentation? That is one important point. That is the segmentation of the continuous gesture. And one important point is the co-articulation. That means the current gesture is affected by the preceding and the following gesture. So one gesture may be the part of another gesture. So this problem also we have to consider. That is the co-articulation problem. So these are the major challenges of gesture recognition. Now again I am explaining the major challenges of the dynamic gesture recognition. So first problem already I have explained, that is the segmentation problem. So for this we have to consider the illumination variation, and the complex background also we have to consider, and also the problem of the occlusion. And in this case the self occlusion is very important. That means occlusion between the fingers, occlusion between the two hands. Suppose if I consider two hands, that occlusion also we have to consider. Another one is the gesture spotting. That means we have to consider spatio-temporal variations. If I consider a continuous gesture, we have to find the starting point and the ending point of this particular gesture. That is called the gesture spotting. And also the difficulties associated with image processing techniques. So the extracted feature should be rotation, scaling and the translation invariant. That means the hand feature should be invariant to rotation, translation and the scaling. And the processing of a large amount of image data is time consuming, and so real time recognition is really very difficult. So these are the difficulties associated with image processing techniques. And if I consider the major challenges of the dynamic gesture recognition, if I consider the problem with continuous gestures, so one problem is the co-articulation problem. That means the current gesture is affected by the preceding or the following gestures. And another important problem is the movement appendices. That is the unwanted movement that occurs while performing a gesture. And another problem is the sub-gesture problem, when a gesture is similar to a sub-part of a longer gesture. So this problem I am explaining in my next slide. The one problem is the co-articulation problem, one is the movement appendices problem, and another one is the sub-gesture problem. And one important problem is that is the problems related to two-handed gesture recognition. It is very difficult in case of the two-handed gesture recognition. One is the computational complexity, and one is the occlusion due to inter-hand overlapping. That already I have explained. That is, if I consider the overlapping of two hands or maybe the overlapping of the fingers, then that is nothing but the occlusion, the self-occlusion. And also simultaneously we have to track both the hands. So we have to do the tracking, and we have to develop the tracking algorithm so that it can track both hands. So these are the major challenges of dynamic gesture recognition. Now I will show in my next slide what is the co-articulation, what is movement appendices, and what is sub-gesture problem. So here you can see I am showing the gestures 1, 2, 3 like this, 1, 2, 5, 7, 3 like this. So if I perform 1 and after this if I perform 2 like this, so one is this extra movement between these two gestures. So this is the extra movement between these two gestures. And similarly from 2 to 5, this is the extra movements between these 2 and 5. So this is called movement appendices. In figure B, I have shown the problem of the co-articulation. That means the current gesture is affected by the preceding or the following gestures. So here I have shown the examples of the co-articulation. And finally, I want to show the sub-gesture problem in C, in figure C. So my gesture is 8, but here you can see 5 is a sub-gesture of gesture 8. So if I want to draw 8, so you can see the 5 is a part of 8. So that is called a sub-gesture. But my gesture is the 8, but by mistake the recognizer can recognize that gesture as 5. So this is called the sub-gesture problem. So these are the major problems in case of the continuous gesture recognition. One is the co-articulation, one is the movement appendices, and one is the sub-gesture. So in summary, I am showing in this figure the problems of the gesture recognition. So the major challenges of the gesture recognition. So first one is gesture acquisition regarding the camera specification, color range, resolution, frame rate, lens characteristics, and regarding the 3D image acquisition, depth accuracy, and also the problem of the segmentation like illumination variation, complex background, dynamic background. And also for the gesture detection, we can consider hand articulation and the occlusion. That is nothing but the self-occlusion. After this gesture representation and the feature extraction, so we may consider static gesture, dynamic gestures, and we can consider the 2D modeling of the gestures or maybe the 3D modeling. But in case of the 3D modeling, it is computationally complex, and in case of the 2D modeling, it is object view dependence, and in this case the problem of the self-occlusion and the hand articulation. So 3D modeling is more accurate, but it is computationally complex. And for dynamic gesture, we have to consider the spatio-temporal variations. So what is the spatio-temporal variation? Suppose if I want to perform the gesture like this is a gesture. So if I repeat this gesture, suppose like this, there will be a spatio-temporal variation. That means variation in the space and variation in the time. If the same gesture is repeated by different users, there will be spatio-temporal variations. And even the same gesture is performed by the same user or the same person, still there will be a spatio-temporal variation. And for the continuous gesture, we have to consider these cases. One is the moment epenthesis, co-articulation, and the sub-gesture problem. And in case of the feature extraction, we have to consider the feature should be invariant to affine transformation, that is RST invariance, and also the object view dependence, and also we have to reduce the dimensionality of the feature vector, that is nothing but the curse of dimensionality. After this, we have to do the classification. So, which classifier is good, that we have to also consider. So, maybe the size of the training data, that is important, the computational complexity is very important, and selection of optimum parameters for validation, that is also very important, and the recognition of unknown gestures. So, these are the main challenges of gesture recognition. So, if you see the vision based gesture recognition architecture, the first, the hand and the image video that can be captured by the camera. After this, we have to do the segmentation of the hand, and after this we have to do the tracking. So, already I have explained this problem is quite difficult because we have to consider dynamic background, maybe the cluttered background, and also illumination variations I have to consider. And if I consider two-handed gestures, I have to track both the hands. So, tracking is also a problem, and segmentation is also a very difficult problem because I have to consider illumination variation and the dynamic background and the cluttered background. After this, I have to consider gesture representation. So, for this I have to do the modeling, gesture modeling. I have to extract features, the feature extraction, and finally I have to select the classifier for recognition. So, this is a typical gesture recognition system. After this, we can consider the detection and the pre-processing. Detection means the detection of the hand, that is the segmentation of the hand, and also I have to do the tracking. So, we may consider these cases. So, skin segmentation techniques we can apply for the image and the videos, and in case of the image, uncontrolled static environment because the background may be cluttered and there may be illumination variations. And in case of the video, we have to consider uncontrolled dynamic environment. The dynamic background may be there, the random illumination variation will be there, the cluttered background may be there. So, all these cases we have to consider. And for image, we may consider region based technique, the edge based technique, or maybe the skin color based technique we can consider for segmentation, or maybe the Otsu thresholding technique also we can use. And in case of the video, we can consider dynamic model adaptation technique. So, for skin color based techniques, we can consider different color models, maybe the RGB color model, HSP color model, YCBCR color model, YIQ model, like this, all these models we can consider to determine the skin colors. And based on the skin color, we can segment out the hand from the background. And for the parametric model, we can consider single Gaussian model, the Gaussian mixture model, or maybe the elliptical boundary models we can consider, and that is corresponding to the skin color based segmentation. Or maybe the non-parametric models we can use, like the Bayes skin probability map, SPM means the skin probability map we can use, the lookup table we can also use, the self-organizing map SOM also we can use, or maybe the ANN model we can use for skin color segmentation. So, based on the skin color, we can segment out the hand from the background for different conditions. So, for vision based methods, so we can consider the model based methods. So, for this we can consider the parameters like the parameters of the hand, like the joint angles, the palm positions, like this we can consider, or maybe we can consider the appearance based model. So, for this we can consider the parameters like images, the image geometry parameters, image motion parameters, we can consider these parameters. And already I have explained about the skin color based segmentation. So, we can apply this technique. So, with the help of the skin color, we can do the segmentation of the hand from the background, or maybe for the tracking we can use the Kalman filter or maybe some filters like particle filters we can use for the tracking. So there are many tracking algorithms, maybe the mean shift algorithm also we can use, but one tracking algorithm is the Kalman tracking, or maybe we can use the particle filter tracking. These techniques we can use for hand tracking. And for tracking already I have explained. So the methods may be like this. So using the pixel level sense we can consider the background subtraction method, we can consider inter-frame difference, the 3-frame difference. So these classical techniques also we can use, and maybe like the mean shift algorithm or the cam shift algorithm, the Kalman filter, the particle filter. So these techniques can be used for hand tracking. And for hand gesture modeling already I have explained. So we can consider different types of models, like in the figure A I have considered the 3D textured volumetric model. So that is the first model, the 3D textured volumetric model we can consider. The second B, the 3D wireframe volumetric model I can consider. In figure 3, 3D skeletal model also we can consider. In figure D, this is the binary Sill-Houghton we can consider, and maybe we can consider a contour model as shown in figure E. So these models we can use for hand gesture modeling. So here again I am showing these models. So that is the gesture representation and feature extraction. So you can see the color models. The first I am showing, that is the 2D model. The Sill-Houghton geometric model, that is the second one, that is a 2D model. Deformable model also we can consider, and similarly we can consider 3D models like 3D skin mesh model, 3D geometric model, 3D skeleton model, 3D textured volumetric model. So these are the model based techniques. And if I consider the appearance based model, that means in this case we can consider shape, color, Sill-Houghton base, or maybe we can consider template models, or maybe we can consider motion based models. So for this we can consider optical flow for motion representation, or maybe we can consider motion templates like motion history image, motion energy image. So by using these motion templates, the motion history image and the motion energy image, we can model a particular gesture, or we can represent a particular gesture. And also we should consider the depth based method on RGB depth data, because if I consider the depth information, the accuracy of recognition will increase, and it will also solve the problem of self occlusion, or it may partially solve the problem of the self occlusion. So the major problems in segmentation like illumination variation, occlusion can be handled nicely with the help of the depth data, and for this we can consider the Kinect based methods. So we can consider the Kinect sensors to get the depth data, or maybe other depth sensors, maybe the lip motion controller we can consider, Sense 3D by Creative, that also we can consider. So different types of depth sensors are available. So from this we can get the RGB depth data, the RGB-D data. So with the depth information, some of the problems can be partially or the nicely eliminated, like the problem of the self occlusion, the problem of the illumination variation. So these problems can be handled with the depth information. And after this, for gesture representation and the feature extraction, so we have to extract the features, and the features should be invariant to affine transformation. So maybe the features may be something like this. The shape information we can consider. So geometric features or the non-geometric features we can consider. Texture or the pixel value we can consider. 2D or the 3D model based features we can consider. Spatial features like position and the motion velocity we can consider. So spatial features may be, suppose if I consider hand is moving, so that means we can determine the motion trajectory, and from the motion trajectory we can determine the dynamic features like velocity, acceleration. So all these features we can determine, and also the position of the hand we can also determine. So this is the motion trajectory, and also we can consider spatio-temporal interest points, that also we can determine, and maybe we can determine the shift feature also, that is also one important feature that can be applied for hand gesture recognition. So in this table I have shown different types of features: generally used in the research papers. So spatial domain 2D features, maybe the fingertips location, finger detection, seal HUT, and maybe the motion scene code can be used like this. So we have already discussed about the scene code. And for spatial domain 3D features, we can consider joint angles, hand location, surface textures, surface illumination like this we can consider. And also we can consider features in the transform domain like the Fourier descriptors, DCT descriptors, wavelet descriptors. And also we can consider the moments, the geometric moments, the 7 moment invariants we can consider. And like the histogram based Hawk features, the shift features, the sharp features, or maybe the combined features we can use. And all these features has the advantages and the disadvantages. So you can see the advantages and disadvantages of these features from the slide, or maybe from my research paper you can see. So what are the advantages of these features and the limitation of these features. And finally we can consider the classification module, that is the recognition module. So after extracting the features, we have to recognize the gestures. So we can apply the supervised techniques or maybe the unsupervised techniques. And maybe we can consider like the conventional methods on RGB data we can consider, or maybe the depth based methods on RGB depth data, or maybe the deep networks that we can use for recognition. So the classical machine learning techniques, maybe the support vector machine, the k nearest neighbor, so all these techniques can be used for gesture recognition, or maybe the deep networks like the CNN, the convolution neural networks. So this can be used or this can be employed for gesture recognition. So for static gesture recognition we can apply maybe the supervised classification techniques like k nearest neighbor, support vector machine, artificial neural networks. For the unsupervised, maybe we can consider the k-means algorithms. And for dynamic gesture recognitions, because for dynamic gesture recognition we have to consider the motion parameters. That means we can consider the motion trajectory, and from the motion trajectory we can determine the dynamic features like the velocity we can determine, the acceleration we can determine, trajectory curvature we can determine from the motion trajectory. And based on these features we can do the classification. So maybe we can consider some techniques like the dynamic programming or maybe the dynamic time warping. This is a very popular algorithm for gesture recognition. Maybe we can consider the artificial neural networks and the probabilistic framework. Maybe we can consider the Bayes classifier also, or maybe the hidden Markov model or other statistical methods we can consider. And maybe we can consider CRF, that is the conditional random field. That is also very important. You can see the research paper on conditional random field. So by using the CRF also we can recognize gestures. So in this class only I will explain briefly the concept of the dynamic time warping and the concept of the hidden Markov model. Now I will discuss the conventional dynamic gesture recognition techniques. So here in the figure you can see I have shown the dynamic gesture recognition techniques. We may have direct methods or maybe the indirect methods. In case of the direct methods, we have to extract gesture features, and based on these features we can do the classification, we can do the recognition. In case of the indirect methods, we may consider non-probabilistic methods or the probabilistic methods. For example, in case of the non-probabilistic methods, we can use dynamic time warping, DTW, and also maybe the artificial neural networks. In case of the probabilistic methods, popular methods are hidden Markov models, that is very important, and another one is the conditional random field. So these are some examples of conventional dynamic gesture recognition techniques. So in this class mainly I will discuss these two algorithms. One is the DTW, dynamic time warping, and another one is the brief introduction of hidden Markov model. So these two algorithms briefly I will explain. So what is DTW? You can see in my next slide. So this is the dynamic time warping algorithm. So this algorithm is mainly the template matching, and it is used in isolated gesture recognition. Suppose in case of the gesture recognition, I have one trajectory, that is the gesture trajectory, because the hand is moving. So from the video I can determine the gesture trajectory. So we have the trajectories of all the gestures. These are called the template gestures or the template trajectories. So when the new trajectory is coming, suppose the new trajectory is this, so I have to do the matching. So the matching between the template trajectory and the input trajectory, that is the test trajectory, and based on this matching I can determine or I can recognize a particular gesture. So I am repeating this, that means corresponding to a particular gesture sequence, the gesture video, I can extract the gesture trajectory, and I have the number of trajectories corresponding to different gestures. So suppose if I consider, suppose if I write A like this or maybe the B like this, so for all this we have the gesture trajectories, and for recognition, for classification, we have to match the input trajectory, that is the test trajectory, with the template trajectory. So one algorithm is very popular, that is the DTW, the dynamic time warping algorithm. So it is a template matching algorithm. So mainly the concept is, suppose I have two time series, one is suppose P and another one is Q. So I have two time series P and Q, and I can find the similarity between these two time series. So for this I can compute the distance between P and Q. You can see I am finding the distance between P and Q. So I can consider Euclidean distance or maybe the Manhattan distance. So any distance I can consider, and based on this distance I can find the similarity between these two time series, one is P and another one is Q. So for this I am considering the warping path W, and corresponding to this I have the W matrix, suppose, and here you can see the matrix element is WK. So define warping between P and Q like this. So W is nothing but W1, W2, Wk like this. So for this what I have to consider, I have to find the DTW between P and Q. In this expression you can see I am finding the DTW between P and Q, that is nothing but the minimum distance between the time series P and Q. So based on this I can find the similarity between the time series P and Q, and based on this I can recognize. So the actual concept I am going to explain in my next slide. So for matching, what we can consider a distance, maybe we can consider Euclidean distance or any other distance, the city block distance also we can consider. But what properties should a similarity distance have? So we can consider the metric distances. The property of a distance measure should be like this: the distance between 2 points, the point A and B, DAB should be equal to DBA, that is the symmetry property, and the distance between the same point DA comma A, that should be equal to 0, that is the self similarity, and also the distance between the point A and B should be greater than equal to 0, that is the positivity, and this is also, you know, that is the triangular inequality. So distance between these 2 points DAB should be less than equal to distance between the point A and C plus distance between the point B and C. So these are the properties of the matrix distances. So based on this we can consider the Euclidean distance. So in the next slide you can see I am considering the distance between suppose 2 points or maybe the two sequences. I am considering X and Y sequences, and I am finding the distance between these two. So LP is the distance, and suppose the P is equal to 1, then it corresponds to Manhattan distance. If P is equal to 2, that corresponds to Euclidean distance. So this distance measure I can consider to find the similarity between the time series P and the time series Q. So for this the basic idea is, let us consider the series, the time series A, that is A1, A2 up to AN, and another series I am considering B, that is B1, B2 up to Bn, it should be Bn, and we are allowed to extend each sequence by repeating elements. So, that means we can extend the sequence. After this, we can calculate the Euclidean distance between these two extended sequence, one is x dash, another one is y dash. So, the x dash means the extended sequence and y dash is the extended sequence, that is the y sequence. So, we can find the Euclidean distance between these two sequences, and in this case we are getting the matrix is M, that is nothing but the elements are like this. Mij is the element of the matrix M. What is the element Mij? That is nothing but the distance between xi and yj. Suppose if I consider these two time series, I am considering one is the green, another one is the red. So, what is the importance of dynamic time warping, that I want to show here. And suppose if I want to match these two sequences point to point, suppose the point I is matched with the point I in the second sequence, then in this case it gives poor similarity score. The point I of the first sequence is matched with the point I of the second sequence. So, it gives the poor similarity score. But actually what is happening here, the point I of the first sequence corresponds to the point I plus 2 in the second sequence. So, we have to find the matching between I and the I plus 2. So, that is why the nonlinear elastic alignment is important. In the previous case, in the first case, I am just considering the point I of the first sequence and the point I of the second sequence. So, it gives poor similarity score. But in the second case, what I am considering a nonlinear elastic alignment. Then in this case, I am getting the good measure, the similarity score, because the point I of the first sequence actually corresponds to the point I plus 2 in the second sequence. So, that is why the importance of the dynamic time warping. That means we need a nonlinear elastic alignment. So, in this figure you can see I am considering the warping function. I am considering the time series A and the time series B. You can see here the time series A and the time series B I am considering. Now, I want to find the best alignment between A and B, and for this I need to find the path through the grid. So, that means I have to find the path. The path is represented by P is equal to P1, P2, P3 like this. So, PS is nothing but IS comma JS. So, what is the best path? That means the best path minimizes this total distance between them. So, what is the best path? The best path minimizes the total distance between the two sequences. One is the time series A, another one is the time series B, and the P is called the warping function. So, in this figure you can see I have shown the warping function P1, P2, P3 like this. So, this is the warping function. So, in case of the gesture recognition, already I have mentioned, so I have to compare the test trajectory and the template trajectory. So, suppose I am considering the DTW algorithm. Suppose I am considering one trajectory something like this, that is the gesture trajectory A suppose, and that is nothing but the suppose template. So, I am considering this is the template gesture trajectory, and after this I am considering the another trajectory, that is the test trajectory something like this. So, trajectory is B suppose, this is the test trajectory, and by this DTW algorithm I can find the alignment between A and B. So, I can find the correspondence between the template A and the template B, that is the template and the test trajectory. So, suppose this is the alignment between A and B that we can find, that is the warping function. So, the best alignment we can find based on the distance between the time series A and the time series B. So based on this, we can recognize a particular gesture. So we have the template gestures, we have the templates, and whenever the new gesture is coming, we have to match the test gesture with the template gestures. But it is time consuming because for one gesture I have to compare with each and every templates. So that is why it is computationally complex. And suppose in the template, if I can identify some of the key points, suppose these are the key points in the template, and from this I can determine gesture features. Suppose I can extract some features like orientation feature, the length feature, or maybe the dynamic features like velocity, acceleration I can determine. And similarly for the test trajectory also I can determine the key points. The key points I can determine, and these key points I can match. These key points I can match based on the warping function. And by this process I can determine the features corresponding to the test gesture trajectory. So you can see I am just doing the matching based on the key points. One is the template trajectory, another one is the test trajectory. In the template trajectory I can find the key points. So maybe something like the MPEG 7, the trajectory descriptors, trajectory representation. MPEG 7 trajectory representation we can consider. So we can determine the sum of the key points like this. So I have shown the key points, and I can find the correspondence between the key points. And after determining the key points in the test trajectory, I can determine the gesture features. The static features and the dynamic features I can extract from the key points, because from these key points of the template I can find the corresponding key points of the test trajectory. And after this we can determine the features, the static features like length between the key points, or maybe the orientations, or maybe the dynamic features like velocity, acceleration I can determine, and based on this I can recognize a particular gesture. So this is one example how to recognize a particular gesture. So we have been discussing about the warping function. So in the next slide also I will explain the concept of the warping function. So here you can see I am finding the time normalized distance between A and B, the time series A and time series B. So that distance I am determining. So DAB is the time normalized distance, and here you can see the distance is divided by the sum of the coefficients, that is the weighting coefficients. So what is DPS? The DPS is the distance between IS and the JS, that is the time series A and the time series B. So for this I am finding the distance between IS and the JS, and I am considering the weighting functions, or I am considering the weighting coefficients WS. So that is the time normalized distance between A and B, because the distance is divided by the sum of the coefficients. So what is the best alignment path between A and B? The best alignment path is nothing but the minimum distance between the time series A and the time series B. So based on this I can find the best alignment path between A and B. So in this case you can see the optimization to the DTW algorithm, because number of possible warping path through the grid is exponentially explosive. So maybe I can consider this warping path, or maybe I can consider this warping path. Like this I can consider many warping path, but which one is the best I have to determine. So that is why I have to do the optimization to the DTW algorithm. So for this I have to consider some restrictions on the warping function. So these restrictions we have to consider. One is the monotonic condition, continuity condition, boundary conditions, warping window size consideration, and the slope constraint. So I am going to explain one by one. So based on this I can find the warping path. So first one is the monotonic condition. So IS minus 1 should be less than equal to IS, and similarly JS minus 1 should be less than equal to JS. The meaning is the alignment path does not go back in time index. So that means it should be monotonically increasing, the warping path. The warping path or the warping function should be monotonically increasing. That means it guarantees that features are not repeated in the alignment. So the features should not be repeated during the alignment. So that is why we are considering the monotonic condition. Next, I am considering the continuity condition. So here you can see I am considering a discontinuous alignment path. The alignment path does not jump in time index. So that is one important point, that the alignment path does not jump in the time index. So there should be continuity. So in the figure I am showing the discontinuity. So what is the importance of the continuity? So guarantees that the alignment does not omit important features. So if I consider the discontinuous alignment path, then that means I may miss some important features. So that is why the continuity condition is important. So these two conditions, one is the monotonic condition, another one is the continuity condition. These are very important. So next slide you can see I am showing the monotonic condition. Here you can see. So it is monotonically increasing, and also I am showing the continuity path. That is I am showing the continuity, that is alignment path does not jump in time index. It should be continuous. Next one is I am considering the boundary conditions. So that means in this figure you can see this alignment path, it is starting from this point and ending at this point. But it should not be like this. So the condition is the alignment path start at the bottom left and the ends at the top left. So that should be the condition. But in the figure I am showing that here you can see the alignment path is starting from this point and it is ending at this point. But actually it should start at the bottom left and ends at the top left. So what is the importance of this? So it guarantees that the alignment does not consider partially one of the sequences. So that is why we have to consider the starting point like this. I1 should be equal to 1 and Ik should be equal to n, and similarly J1 should be equal to 1 and the ending point should be Jk is equal to m. So here you can see I am showing the actual alignment path based on the boundary condition. So the second one is the alignment path considering the boundary conditions. Next point is warping window. So that means in this case I am defining the window size. So which one is the best window I am considering? So Is minus Js should be less than equal to R and R should be greater than 0. So that means I am considering the window length. So a good alignment path is unlikely to wander too far from the diagonal. That means the best alignment path will be very close to the diagonal. So alignment path should be close to this diagonal. So that means what is the importance of this? It guarantees that the alignment does not try to skip different features and get stuck at similar features. So that is why the window size is important. So here in the figure you can see I am showing the window, the length of the window I am considering R is the length of the window, and based on this window I can see the alignment path like this. It is close to the diagonal. So it should not wander too far from the diagonal. So that is the concept of the warping window. So this condition also we need to consider. And finally the last constraint, that is the slope constraint I am considering. So this equation is nothing but you can see I am considering the slope and also I am considering the slope. So what is P? P means the number of steps in y direction, and what is Q? The Q is the number of steps in x direction. I am considering both the directions, one is the x direction, another one is the y direction. So in this case the Q is the number of steps in the x direction and the P is the number of steps in y direction. So that means in this case the condition is the alignment paths should not be too steep or too shallow. So what is the importance of this constraint? That means it prevents that very short parts of the sequences are matched to very long ones. So that is the slope constraint. So we have to consider all these constraints, the monotonic constraint, the continuity constraints, the slope constraint, window size, all this we have to consider corresponding to the warping function. So here I am considering the time normalized distance between A and B, and here you can see the distance between A and B I am considering, and this distance is normalized by the summation of the warping coefficients. So now I am considering C is equal to the summation of Ws, it is starting from S is equal to 1 to K. So Ws is nothing but the weighting coefficients, and this weighting coefficient function, it should be independent. So I am getting C is nothing but the summation of Ws, S is equal to 1 to K, and it should be independent of the warping function. So that is why, since it is independent of the warping function, so I am taking it out. So it is 1 by C minimum, and this I am the distance, this I am considering. So that means I am considering the distance between A and B, and that is nothing but the time normalized distance. And this, the distance DAB I can determine, and it can be solved by considering the dynamic programming. So there are two forms, one is the symmetric form, another one is the asymmetric form. In the symmetric form, the weighting coefficients we can determine like this: Ws is equal to Is minus Is minus 1 plus Js minus Js minus 1, and C is defined like this: C is equal to n plus m. And similarly, if I consider the asymmetric form, corresponding to the asymmetric form, Ws is this, and C is equal to n, or maybe C is equal to m. So I may consider the symmetric form or the asymmetric form for solving the dynamic programming problem. So here you can see I am considering the symmetric DTW algorithm, and I am not considering the slope constraint, I am not considering. And you can see the warping window that is defined between these two yellow lines. So this is the warping window I am considering between these two yellow lines. And initial condition also we have to consider, that is Z11 is equal to 2D11. That is the initial condition for the dynamic programming. So this DP equation, the dynamic programming equation, we can employ, and this warping window we have defined, and we can determine the time normalized distance, and C is nothing but n plus m. So this symmetric DTW algorithm we can employ, and that means we are considering the distance between the time series A and time series B, and we have shown the window, the warping window we have shown. And similarly, we can consider the asymmetric DTW algorithm. Again, in this case, I am defining the window, that is the warping window I am considering, and slope constraint I am not considering, and this is the initial condition for the asymmetric DTW algorithm. And we can consider the DP algorithm, the dynamic programming equations corresponding to asymmetric DTW algorithm, and from this we can determine the time normalized distance, the DAB we can determine, and in this case we can consider C is equal to n. So this symmetric DTW algorithm or the asymmetric DTW algorithm we can employ to find the time normalized distance. That means I want to find the alignment between time series A and the time series B. And also we can consider the quasi-symmetric DTW algorithm. The concept is very similar, but the initial condition is this: Z11 is equal to D11, that is the condition, and we can consider the dynamic programming equations like this. Gij we can consider. So this is from the dynamic programming equations, and we can consider the warping window, and we can determine the time normalized distance we can determine. So this DTW, one is the symmetric, one is the asymmetric, and one is the quasi-symmetric DTW we can consider. So now let us see one example how we can find the best alignment between time series A and the time series B. So here I am showing the time series A and the time series B, and I am also showing the window that is between two yellow lines. So first the start with the calculation. So first we are considering G11 is equal to D11, that I am considering. After this, the calculate the first row. You can see in the figure here, I am calculating the first row by this dp equation. Gi1 I have calculated, the first row I have calculated. After this, calculate the first column by using this dp algorithm, the dp equations. Move to the second row, that means I am considering the second row. If you see the figure, move to the second row, that is Gi2. We can determine Gi2, that is the minimum of Gi1, comma Gi minus 1, 1, comma Gi minus 1, comma 2 plus Di2. And after this, keep for each cell the index of this neighboring cell which contributes the minimum score. So that means the minimum score, the distance we have to consider, and that is shown by the red arrows. So in the figure you can see I am showing the red arrows. So keep for each cell the index of the neighboring cell which contributes the minimum score, that we are considering. And carry on from the left to right and from the bottom to top with the rest of the grid we have to consider, and based on this Gij we can determine by these dp equations. So pictorially again I am showing here. So first we have calculated the first row, and after this we consider the first column. After this we are considering the second row. After this we have to consider Gij. Like this we are computing by using the dp equations. After this, trace the best path through the grid starting from Gnm and moving towards G11 following the red arrows. So that means I am finding the best path I am determining. So how to find the best path? You can see it again. So trace back the best path through the grid starting from Gnm and moving towards G11 by following the red arrows. So that means I am getting the best alignment path between the time series A and the time series B. So this is the brief concept of the DTW algorithm. So if you want to see the detail of this DTW algorithm, you can see the book. Even in the speech recognition book you will get this algorithm, the DTW algorithm, the book by Rabiner, or maybe the research papers you can see for this algorithm. So DTW algorithm. So briefly I have explained the concept of the DTW algorithm and how it can be used for gesture recognition. But the main problem already I have explained. The main problem is the computational complexity, because I have to compare the test template with all the template trajectories. So it is computationally expensive. So this is about the DTW algorithm. Now let us consider the concept of the hidden Markov model. So briefly I will explain this concept, the hidden Markov model. So a particular gesture trajectory is represented by a set of feature vectors where each feature vector describes the dynamics of the hand corresponding to a particular state of the gesture. So that means we are considering the feature vector describing the dynamics of the hand corresponding to a particular state of a gesture, that we are considering. The number of such states depend on the nature and the complexity of the gestures. So number of states of the hidden Markov model depends on the nature and the complexity of a particular gesture. The global HMM structure is formed by connecting in parallel the train HMMs, that is the train HMMs are lambda 1, lambda 2 like this, where G is the number of gestures to be recognized. So for each and every gestures I have the train HMM. So now I am showing the hidden Markov model. So Markov chain I have shown. So it has number of states S1, S2, S3, S4, S5 like this, and I have shown the transition from one state to another state, the transition from S1 to S3, the transition from S1 to S2, the transition from S3 to S4 like this you can see, and with the probability, suppose the transition from S1 to S3 with a probability the 0.5, and also I have shown the self transition. You can see in case of the state S2 the self transition is taking place with the probability is 0.7. So transition from one state to another state I have shown here. That means hidden Markov model has finite set of states and each of which is associated with a multidimensional probability distribution. And also you can see already I have defined, that is the transition among the states are governed by a set of probabilities called transition probabilities. So in the figure I have shown the transition probabilities like 0.5, 0.1, I have shown the transition probabilities. In a particular state, an outcome or observation can be generated. So corresponding to particular state, I can see the outcome or the observation can be generated according to the associated probability distribution. And why it is called a hidden, I will explain. So it is only the outcome, not the state visible to an external observer, and therefore states are hidden to the outside. Hence the name is the hidden Markov model, because I am considering the Markov chain. And why I am considering the term hidden? Because the states are not visible to an external observer. So what is visible? Only the outcome is visible. So that is, it is only the outcome, not the state visible to an external observer, and therefore the states are hidden to the outside, and that is the name is the hidden Markov model. So that is the concept of the hidden Markov model, the brief concept. And what are the elements of the hidden Markov models? So first, the clock. So the clock is defined like this, the t is equal to 1, 2, 3, this is the clock, and corresponding to this I have the n number of states. Q is the states 1, 2, 3, so n number of states are available, and number of observation symbols. So observation symbols I am considering O, V1, V2, V3 like this. So number of observation symbols I am considering, and the initial probabilities of the states is defined by pi j. So this is the initial probabilities of the states, that is also defined, that is the pi j, and the transition probability, that is aij. So transition from one state to another state, that is also defined, the transition probabilities. And the observation probabilities also it is defined, that is the bj, it is defined, the observation probabilities corresponding to a particular state. So in this case, so what are the main elements now? What are the main elements of the hidden Markov model? One is the matrix A. So in the matrix A, the elements are aij. So what is aij? That is the transition probability. What is the B? The set of observation probabilities. And what is pi? The pi is nothing but vector of pi j values, that is the initial probabilities. So that means the hidden Markov model is defined by this del lambda. So lambda is a, b, pi. In case of the gesture recognition, for each and every gesture I have one hidden Markov model. So suppose the lambda 1 corresponds to the gesture 1, lambda 2 corresponds to gesture 2. So like this I have number of hidden Markov models corresponding to each and every gestures. So hidden Markov model is represented by these parameters, one is a, another one is b, another one is pi. So one is the matrix of aij value. So what is this? Nothing but the transition probabilities. The b is nothing but the observation probabilities. The pi is nothing but the initial probabilities. So the model is represented by a, b, pi. So the hidden Markov model, you can see the state transition distribution A, which gives the probability of transition from the current state to the next possible state. So in case of the hidden Markov model, you can see here the state transition probability distribution A, which gives the probability of transition from the current state to the next possible state. So this is the transition probability distribution A. What about B? The observation symbol probability distribution B, which gives the probability of observation for the present state of the model. That is nothing but the observation symbol probability distribution. The initial state distribution, that is pi, which gives the probability of a state being an initial state. So that is the definition of AB pi. So in case of the hidden Markov model, so these parameters are important. One is A, another one is B, another one is pi. So this is the hidden Markov model. In case of the hidden Markov model, we have three problems, the basic problems. The first problem is the evaluation. So given the model is represented by AB pi. So what we have to determine, what is the probability of occurrence of a particular observation sequence, that is the gesture sequence. The gesture sequence is represented by O1, O2, O3 like this. So this is the gesture sequence, and we have to determine the probability of O given lambda. Lambda is nothing but the model, and this is a classification or the recognition problem. This is actually the determination of the probability that a particular model will generate the observed gesture sequence when there is a trained model for each of the gesture classes. So this can be obtained by the algorithm. The algorithm is the forward backward algorithm. So I am not explaining this algorithm, so you can see the research papers on this. So what is the forward backward algorithm? The problem is the probability of O given lambda that we have to determine. So that is the recognition problem. What is the decoding problem? The decoding problem is determination of optimal state sequence that produces an observation sequence. So this algorithm is called the Viterbi algorithm. Also you can see this algorithm, what is the Viterbi algorithm, but this problem is called the decoding problem. But one important problem is the learning problem, that is the training of the hidden Markov model. Determination of the model lambda given a training set of observation. That means we have to find lambda such that the probability of O given lambda is maximal. This is nothing but the training of the hidden Markov model. Train and adjust the model to maximize the observation sequence probability such that HMM should identify a similar observation sequence in the future. So this Baum-Wells algorithm also you can see. So these algorithms are very important. One is the forward backward algorithm. For this problem, the problem is we have to determine the probability of O given lambda. And the decoding problem, that is nothing but the Viterbi algorithm. And the learning problem, that is the training of the hidden Markov model. So we have to maximize the probability of O given lambda. So for this we can consider the Baum-Wells algorithm. So in case of the hidden Markov model, what are the main problems? So we must know all the possible states in advance. That means we must know possible state connection in advance. So for all the gestures we have to consider this. That means we should know all the possible states in advance. Also we should know the possible state connection in advance. And this HMM cannot recognize the gestures or the things outside the model, because already I have explained. So first we have to form the model, we have to train the model by using the Baum-Wells algorithm, and after this we can recognize, but it cannot recognize things or the gestures outside the model, and it must have some estimate of state emission probabilities and state transition probabilities. That means it must have some estimate of state emission probabilities and state transition probabilities. And the hidden Markov model make several assumptions. So these are the problems with the hidden Markov model. So in case of the hidden Markov model, every gesture model has to be represented and trained separately, considering it as a new class, independent of anything else already learned. And in case of the hidden Markov model, requires strict independent assumptions across multivariate features and the conditional independence between the observations. So this is one important requirement. This is generally violated in continuous gesture recognition. So for continuous gesture recognition, we have to modify the hidden Markov model. So in the research paper you can see that in case of the continuous gesture also we can apply the hidden Markov model. The hidden Markov model is generative model that defines a joint probability distribution to solve a conditional problem. So that is why we can consider another model, that is the conditional random field. This is very popular in case of the gesture recognition. CRF is a discriminative model that uses a single model of the joint probability of the label sequence to find conditional densities from the given observation sequence. So, the main concept of the CRF, it is the discriminative model, and it uses a single model of the joint probability of the label sequence to find conditional density from the given observation sequence. So, this concept you can also see from the research papers. Just I am mentioning the concept of the hidden Markov model and the conditional random field. And finally, nowadays or most recently, the deep networks are used in case of the gesture recognition. So, maybe we can use something like the convolution neural networks, or maybe the recurrent neural networks, the long and short term memories, the concept in the recurrent neural network. So, these type of networks are recently used for gesture recognition. You can see that recently the deep learning has erupted in action, and gesture recognition fields achieving outstanding results and outperforming non-deep state-of-the-art methods. Like the state-of-the-art method is hidden Markov model, DTW, like this. So, nowadays or recently the deep learning techniques are used, and the popular networks are the CNN or maybe the recurrent neural networks. So, these type of networks are used for gesture recognition. So, in this class I discussed the basic concept of the gesture recognition, and I have highlighted some of the applications of the gesture recognitions. I discussed the concept of the static gesture recognition and the dynamic gesture recognition. For dynamic gesture recognition, we can consider the hidden Markov model or maybe the DTW. So, briefly I have explained the concept of the DTW algorithm and also the hidden Markov model. So, for more detail, you can see the related research paper on gesture recognition. So, there are many new techniques available for gesture recognition. So, you can see all these concepts in the research papers. So, let me stop here today. Thank you.